1/2 times 3 is equal to what times 1/2? What's the reciprocal of 3? Alice? 1/3. So what should go in the box? A 1. And if we multiply 1/3 and 1/2, can I just multiply across?
Yes.
Yep. What's 1 times 1?
1.
3 times 2?
6.
Okay, so here's what we think our answer is, right? Let's use a model to check ourselves. What kind of model am I using? Yes, Arlene, area model. And how many pieces do you want to split it up into first? Into 3? Would it be wrong if I split it up into 2 parts first? No, you can do either one first. Does not matter. Okay, so I've split it into 3 parts first. How many thirds do I need to shade? 1. And I need to label it. Okay? What else do I need to do to my model to show 1/3 times 1/2? Kai? Divide it into 4? Why? I've got thirds and halves. So I've modeled thirds. Now I need to model half of that, right? So if I cut it in half, how many halves do I need to shade? 1. And of course, always label it. So how many parts are shaded both orange and green, Nathaniel?
1/6.
How many parts are shaded both orange and green? Unique. Huh? I want you to tell me the numerator. How many parts are shaded orange and green? Just 1. And how many parts total, Nathaniel?
6.
6. Good. 1, 2, 3, 4, 5, 6. So 1 out of 6 parts. Did we get the same answer? Yes, we did. Yes, Kai?
What I did it slightly different. I didn't count all of this. I just multiplied 2 times.
You multiplied what?
I multiplied the 2 denominators and got 1/6.
Mm-hmm. That's what we did first. 3 times 2 is 6. 1 times 1 is 1. We're going to do it this way so that we can, 1, understand what's happening. So we represented 1/3, and then we cut it in half so we can see why 1/2 of 1/3 is 1/6. It's also a great way to check your work. Do it 2 different ways. If you get the same answer both ways, you can be pretty confident about your answer, right? Let's do number 2. 1/3 divided by 4 is the same as 1/4 times what? Yeah. Can you say it louder?
1/4 times 1/3.
Good. 1/4 times 1/3. Because they've already shown us the reciprocal of 4, it's 1/4. We're keeping our 1/3. We just need to move it over. 1/3 times 1/4, 1/4 times 1/3, same thing. So if I wanted to solve this, could I just multiply across? Yep. What's 1 times 1? And 4 times 3. Good. Now let's model it. I need to draw an area model. How many parts do you want to split it up into first, Ansa? 4. So, and how many fourths do I need to shade? And label it. Okay, let's do the other direction. What do I need to split my fourths into now, Darlie? Yes, sir? 3, or thirds. And how many parts should I shade? 1. Label it. How many parts are shaded both blue and orange? 1. How many parts total? 12. Did we get the same answer twice? Yep. 3, 4, and 5 don't require us to draw a model. You can to check your work. We're going to go through and do the math. How do I write this as a multiplication problem, Hillary?
1/4 times 1/5.
Yep. And 1 times 1 is?
1.
4 times 5 is?
20.
Yep. Go, Isaac. Okay, now the next one, 3/4 divided by 5. How do I write it as a multiplication problem, Unique?
1/5.
And what do you get?
3/20.
Or 3/20. Last one, 1/5 divided by 4. How do I write it as a multiplication problem? Amaya. 1/5 divided by 4.
Yeah, 1/5 divided by 4. Well,
I need to write it as a multiplication problem.
1/5 times 4. No, I don't know.
Yes, Jennifer.
1/5 times 1/4.
You can't just change the sign. You have to change the sign and use the inverse or reciprocal fraction. And what do you get, Amaya?
1/20.
Yes. So remember, reciprocal fractions. Okay, here's some examples. I've written these on the board too. 3, the reciprocal of 3 is 1/3, right? Because 3 is 3/1. So if we flip it, you get 1/3. If I'm moving from a fraction like 1/8 to a whole number, what's the reciprocal of a 1/8? Alice? 8. Because 8/1 is 8. So when you're dividing by a fraction by a whole number, it's the same as multiplying by the reciprocal fraction. Because these problems, every problem that we've done today, including our examples, okay, they took a whole and they divided it into a number of parts. So our whole here was 3/4 of a gallon. How many parts did we divide it into? 2. Our whole here was 3/4 of a pan. We divided it into 6 parts. Our whole here was 2/5 of a meter. We cut it into 4 parts. This is called partitive division. Okay, it's on the whiteboard and it will stay there. But it just means dividing a whole into equal parts. Partitive division, parts, partitive. Okay, go ahead and turn to your problem set on page 5. Okay, just a moment. Amanda, go. You're working on page 5 on your problem set independently at a level 0. Okay, I'm coming around to make sure you're on the right track. Here's what to look for. Okay, I'm going to ask you to track the board and please stay still. We're not fussing with papers yet. Okay, if I write an F you need to check your fraction because you do not have the correct fraction at all. You've calculated something incorrectly. If I write an R, you need to reduce your fraction. If I give you a check mark, what does that mean?
Good.
Good. You're all good, on the right track, okay? What level are you working at, Aisha? 0. You're working with your partner, Coral? No. Go ahead and get started.